I'm having my doubts about the regime that I'm using at the moment, where I tend to... It was a result of the disturbance of my hours coming back from Hangzhou, where I gave a keynote speech, and I got the flu. And I was sleeping during the day because the flu just killed me. So all my hours got chopped up. And now I seem to have settled into a system where I'll wake up about 9 PM and then work through the night and then film during the daylight when when the sun comes up. But the problem with it is that it's towards the end of my waking period, and hence I'm starting to fade, and my brain's not as awake as it should be. So I'll probably modify it. You would think after... How many months have I been doing this deGarisMPC stuff now? I think I started filming like the introductory videos early May. So June, July, August, September, October, November. So it's almost 6 months, right? Yeah, it's almost 6 months. So you'd think I would have settled into a routine, a stable regime. But no, it just things keep popping up and everything changes. And okay. Now, on this board, we'll do a few more examples of languages that are proven to be undecidable. And I must say, if this is the first time you've done this kind of thing, it's a sobering experience, right? You get the impression, gosh, God, there are all these things that computers cannot do, and it certainly counters some vague impression you may have had before that computers are sort of invincible. They can do almost anything. But no, there's lots of things they can't do. And by the end of this course, well, the end of this this chapter and the next one. The next one is advanced topics, I think, on the same theme. Just check the chapter titles. So, Chapter 6, that's the next one. Advanced Topics in Computability Theory. It's about the same length as this one, about 25 or so pages each. Anyway, so by the time I've finished this chapter and the next, you should come away with a pretty strong impression of the lack of invincibility of computers. There are lots of things that machines can't do, and fairly soon we'll start doing examples of problems that that are easy to state and quite useful. It'd be useful to have solutions to such problems. I can feel myself fading. You probably noticed. So I'll probably change things again. So maybe like my wife. Just a minute. My wife finally got around to buying a light. Now, with this kind of light, it'll be diffuse because the bulb inside it, its light, will not come from a concentrated source from the point of view of my eye looking at it. I will see a diffuse lighting. So what I might do, once this goes up, which should be soon, what I might do is write the board using this light sort of early morning, and then film from early morning instead of sort of like 10 or 11 AM, but maybe 7 AM or something. And that way I'd be fresher. I might try that. I keep trying things. It's 6 months and I still don't have a routine. Right, so we will do a few more examples of proofs using reduction. And I'll go over that a little bit again because it's an important concept. And then we will do one proof that does not use the language ATM as the means to prove the undecidability of some second language, some other language. We will actually use one of the languages that we previously used ATM for to show that this other language is undecidability, but we will use look, I better. Well, by the time I've explained it, I'm going to have to do it anyway. So, but just the idea is that we won't always be using ATM as the source to prove undecidability. We'll start using other languages as well that have been proven to be undecidable using ATM. Okay, so right now we're in the middle. At the end of the previous session, we finished off the proof idea, and it was getting fairly tough. And so we'll now finish off the proof. What were we trying to prove? You can remember it was the undecidability of the language ETM. And here I've put it up again. Here it is in language form. So it's the set of all descriptions of Turing machines, such that the language of that Turing machine, each Turing machine, is empty. In other words, it's the set of Turing machines that reject all strings. Now, if they reject all strings, then obviously the language they recognize is the empty language, because there's no string that's in that language. They all get rejected. Okay. So this language of all the description of all Turing machines that do reject all strings, that cannot be decided. That's what we're trying to prove, right? And a bit of revision, because it's a constant theme that we go through quite a few times. So let's see. Reduction. So what's the basic idea? A bit of revision, useful revision. So you hear the term reducibility or reduction, and you automatically think in terms of two problems. Okay, problem A, problem B. To reduce problem A to problem B means that you can take the solution of problem B that's already known, and that the solution to problem B will enable you to find the solution to problem A. Okay, that's what reducibility means. Now, there was another important result that we use quite a few times, in fact, to prove the undecidability of a language, and equivalently a corresponding problem. Remember, Sipser's whole approach is he translates problems into languages, and I think I might untranslate a bit, just again for refreshment purposes. Oh, by the way, flu. Definitely getting better. I think I picked up the virus Sunday, Monday, Tuesday. Oh, by the way, America votes today, so I may be watching the results late into the night. And in 2 days, China, because that's where I live, in 2 days China will announce its new leaders. So big week politically. The two most powerful countries in economic terms on the planet change their leaders. Interesting. With two totally different systems. One that's spreading all across the planet, the whole world is democratizing, and the other, my guess is, has max 10 more years or so to